So I am recording now, and I'm going to start sharing my screen. So am I in presenter mode there now?
Yeah, we're all good now.
Perfect. Hello, everyone. Thank you for attending the 2021 CLRA conference, virtual this year, of course. Pleasure to be here with you today. I'm with my colleague Curtis Trefry from Arctic Canadian Diamond Company under a new name as of recently. Very exciting. And of course, I'm Robert Lacey from Delta Remediation. Today, we're here to discuss a case study of bioremediation in the Arctic, where we treated some mixed hydrocarbons, including long chains, in a pretty harsh environment. So Curtis and I will be doing the talk together, sort of going back and forth. And of course, we'll be happy to answer any questions that you do have in whatever format they'll be presented in. So before we get into the nuts and bolts of the presentation, I just wanted to provide a brief overview of what the expectation or the outcomes might be from today. So Curtis is going to tell us about the Ekati mine, its operations history, some of the challenges that they have in accessibility, and of course managing hydrocarbon impacted soils given some of those challenges. I'll be presenting a little bit on Delta Remediation, the company overview. I'll be speaking about BioLogix bioremediation, which is our primary focus. We'll be discussing what we consider to be good candidates for bioremediation. It certainly is a robust technology, but it is not a silver bullet. And so we want to make sure that we're going after projects that are going to really speak well for bioremediation as a technique. And then, of course, we'll jump into the case study, getting into the equipment and the methods used to process about 1,000 cubes of soil. It's actually 1,400 cubes, including some oversize that we were able to scalp off and not have to treat, but I'll let Curtis discuss that in further detail. And then we'll just review the results and the economic impacts and speak of some project conclusions. So I'll let Curtis take over from here and speak about the Ekati mine site.
Okay, thanks, Rob. Yeah, so I'll lead off with a brief history of the Ekati diamond mine itself. We are Canada's first diamond mine in operation since 1998, located 300 kilometers northeast of Yellowknife, the Northwest Territories, and 200 kilometers south of the Arctic Circle, 100 kilometers north of the tree line, so kind of the middle of nowhere. It receives harsh climatic conditions, low average annual temperatures. There's only 4 months a year that they average monthly temperatures even above freezing. And it's a semi-arid, really dry area that way. So not exactly the best situation for bioremediation to take place. It's a remote mine accessible by air most of the year and then by winter road 2 to 3 months a year. So there's an airstrip on site that's how all the employees come in and out for their normal rotations. And then the winter road is accessible for those 2 to 3 months a year just for equipment, all the fuel that you need for the entire year to run a mine, and everything else is brought to site. So there's some significant logistical challenges that come along with that. We can move on to the next slide. And this is just the winter road that we were talking about there. So the Tibet to Contoito winter road, it's operated as a joint venture between the 3 operational diamond mines in the area. So Diavik, Ekati, and Gaucho Quay. The total length of the winter road is 600 kilometers, of which is about 400 kilometers to get to Ekati. You can see Yellowknife there at the very, very bottom of the map, and Ekati is the furthest north of all the mines. So it's quite a journey to get anything in or out of the mine. We can bounce to the next slide. I'll just fill you in on just some of the life of mine changes at Ekati over the years. The mine itself was originally planned to last 15 years, and that would include 4 kimberlites. For those of you not as well versed in diamond mining processes, kimberlites are the geological formation that diamonds are found in. So originally there was Panda, Koala, Misery, and Fox. Our current life of mine, completing just the active kimberlites, would push us to 2025. That would include Sable, Pigeon, and Misery Underground. And we've got a permitted J project that would push the life of mine to 2035. So in total, there are 10 kimberlites, 3 of them active, 1 permitted and approved by the Wikisi Land and Water Board, and 6 of them that are complete and moving into a closure phase. Really, the point I want to get across here is that the life of mine's been extended significantly from the original plan. which the designs were made for infrastructure such as Landfarm facilities and anything else on site. We can go to the next slide. So the Landfarm is the designated location for remediation of contaminated materials on site. As I'd stated previously, it was based on original life of mine projections of a 2013 closure and built to a capacity of 3,400 cubes. Overcapacity issues were causing the facility to functionally operate only as a containment cell. Basically, there was too much material in there. We couldn't even get equipment in to turn it over, and the windrows themselves were frozen to the core through most of the year. So in 2017, a screener was purchased to facilitate the bagging and removal of Landfarm soils. And basically the way that works is any material greater than 4 centimeters in diameter, cobbles, rocks, whatever else larger aggregates are able to be, we're permitted to deposit them in an area known as Zone S, it's basically a pit in the top of a rock pile where non-remediable material will go and eventually get capped within the rock pile. And then any of the fines below that threshold would get bagged in 1 cube mega bags and hauled off site on that winter road at an astronomical cost. In 2017, we were able to remove 1,000 cubes of soil from that Landfarm using that screener. Unfortunately, in that same year, we undertook the Old Camp Remediation project, where another 2,000 cubes of material were brought into the Landfarm. So based on that, we were falling behind on our capacity issues that were already in place, even though we were working to remove material from the Landfarm on site. Next slide. And it's those challenges that brought us to the partnership with Rob and his team at Delta and the Landfarm Bioremediation pilot project on site. The Landfarm capacity issues and the high cost of winter road utilization for contaminated soil disposal led to search for alternatives. It was costing us $464 per cube to follow that process I discussed of running the soil through the screener that you can see off to the right, bagging the fines and hauling it off on the winter road. Our thought on a potential solution that we could utilize on site would be treating contaminated soils through microbial augmentation. We set up an initial trial of 1,000 cubes treated with BioLogix solution in partnership with Delta Remediation. This has included naturally occurring microbes selected for their ability to degrade hydrocarbons, primarily Pseudomonas. This was a potential to be a cost-effective remedial method to pass CCME agricultural guidelines, which are the limits that we're permitted to adhere to under our water license and interim closure and reclamation plan. So now I'll hand it off to Rob to discuss the ins and outs of the project itself. You're on mute there, Rob.
Thanks, Curtis. Great summary of the history of the mine. Quite an exciting project. Certainly one of our most memorable projects that we've worked on. So yeah, proud to have been partnered with Curtis and his team on this. So a little bit about Delta before we get into the site. So Delta Remediation is an Alberta company. We were established in 2014. We started off as a service provider providing bioremediation services to the oil and gas industry in Northeast BC and in Alberta. And fast forward 5 years to where we are today, I guess 6 years to where we are today now. We still service projects across Canada as a turnkey solution, but we also have developed and export our BioLogix technology into foreign markets around the globe. So we're very big into working with others. We love to sort of compete smart. We've actually been able to develop some strategic relationships with some other remedial providers. We believe that we have a tool in the toolbox, but we always believe that there are many tools that should be considered in remediation. Our focus has been around the sustainable management of soils and water. We saw a lot of disposal or sort of relocation of materials as the primary remediation method, and we thought there was room for improvement. And so we're certainly seeing that today, that more and more clients are looking for end of life cycle for contaminants and looking to save money on doing waste management. And one of the key sort of phrases that we use when describing our process is that it doesn't have to cost more to do the right thing. So this is certainly a cost competitive program. You'll see that we were able to save Curtis and his team some substantial savings compared to offsite disposal. And yeah, we're very happy to be here to speak about the project today. And for some reason I can't click. Here we go. So before I get into the specifics of the project, I just wanted to quickly touch on bioremediation. It's a term that many of you in the industry have probably heard. You know, doing nothing is actually bioremediation, natural attenuation or long-term monitoring. We're hoping that the indigenous or you know, the organisms that are on site will degrade the pollutants on their own. We know from our own experience that in some cases this isn't the case, especially with more complex hydrocarbon chains and especially more complex environments. So that's where bioaugmentation comes in. That's what Delta Remediation specializes in, where we're actually augmenting the microbial population with known degraders that have an affinity for hydrocarbons. And especially like Curtis said, a lot of the technology that we're based on is based on Pseudomonas genus bacteria. But we do have access to hundreds of species of fungi, archaea, and of course, different bacterial species as well. Within Canada, you know, we see a great opportunity, obviously brownfields, complex sites, any petroleum hydrocarbon impacted site that can be accessed through a remedial strategy would be a candidate for bioremediation. However, you know, we're typically going after more complex sites that are going to present a value proposition for handling materials on site as opposed to taking them to the landfill. You know, we're business people first. We understand that for a project to make sense, it needs to make sense financially. And so we understand that there still is certainly a place in the market for landfills. But when you talk about, in this case, you can see on the right a picture of a helicopter. You know, flying bags of soil out isn't very cost effective, nor is trucking them 600 kilometers one way on an ice road. So obviously we saw some value proposition working with Curtis and his team on their remote site remediation. So the BioLogix technology, that's what we're here to talk about. That's what was able to successfully turn this site around for Curtis and his team. Bioaugmentation, it is a culture. So we have our culture comes in a powdered format. It's rendered on a dextrose carrier. We take the powder, we mix it with water, certainly a specific amount of water for a specific amount of time, depending on temperature. And that's what we call our inoculation process. When we have the availability to include beneficial chemistries with our process, we certainly do. And we also like to rely on our field experience, our application understanding as a critical part of successful bioremediation. Daryl Nelson, who's a leader in the industry, thermal remediation expert, he told me years ago when I got into the business that remediation is a contact sport. And what we mean by that is that whether you're using thermal remediation, chemical remediation, or bioremediation, you need to have contact between the technology and the contaminant. If you don't have contact, then you shouldn't expect results. So making sure that we have good, even distribution of the liquid microbial solution within the soil matrix is a critical component to success. I'll speak a little bit more in depth on some of the chemistries in an upcoming slide. But speaking to the biology, what is it that makes BioLogix you know, a leading product in the bioremediation space? Number one is the biology itself. Pseudomonas bacteria are widely known amongst the science community as the leading degraders of organic toxic substances. We have applied 6 of the most aggressive species in a very concentrated formulation in our product. Our products are manufactured in a biopharma facility that has the highest level of QA/QC. This is important, obviously, for the reputation, not only of the safety and usability, but also the efficacy of the product in the field, but more importantly, for the safety of our personnel and the safety of the public. We need to be assured that there are no pathogens or otherwise harmful materials or organisms in our product, and we have that quality assurance through our process. I mentioned earlier that the product is manufactured on dextrose. This is a fully soluble carrier. It also acts as a carbon source for the material when it's growing in its inoculation stage. So sort of a double-edged sword there. And like I mentioned earlier, with the chemistry, surfactants, nutrients, oxidants, these things can all be beneficial, but they're all compartmentalized. Our solutions are all custom built for each project. So for instance, a surface spill on water, we're not going to use surfactant. A lot of our competing products have a surfactant in a liquid, and so you can't get away from using the surfactant. Whereas with our product, we certainly build a custom approach for each site. And I've mentioned earlier about our inoculation, where we actually take the culture, which comes activated into billions per gram cell count, and we can grow it into trillions per gram before we introduce the product and the culture into the contaminated media. The chemistry, the beneficial chemistries, I'm sure that people have heard of surfactants. You know, they're used in push and pull, groundwater remediation. You know, there's three main benefits to having surfactants included in your remedial design. One is that it'll actually break down the surface tension of soil matrices, allowing the water to penetrate those soil pores further, carrying the microorganisms again with it, ensuring better contact. It's also going to physically break down the size of the materials. So people have asked me before if you can see bioremediation working, and you can't see the microorganisms working unless you're looking at 1,000 times microscope. But you certainly can see the soil piles that have been treated with our surfactant, and those soil piles are breaking apart. They're darker in color because they're allowing more water to penetrate the soil matrix. And then the third reason why we like to utilize surfactants is that they'll actually release some of the sorbed contaminants, making them more bioavailable for the microbes to degrade the hydrocarbons in a similar way to soap removing oil or grease from your hands. We also just touched quickly on nutrients. Nitrate is high up on our redox chain. So when we're looking at amending background soil nutrients, this soil specifically was very coarse in material, didn't have much organics, didn't have much for background nutrients. You know, we talked to Curtis and his team and found out that they actually had a nitrate source on site that wasn't being utilized. It was a blasting agent that had been contaminated and wasn't going to be used for blasting, but we were able to use it within our remediation process. And so that's, you know, again, not something that's always required, but certainly is benefit. And if there was, you know, a minimal cost to integrate that, then we do so. I won't spend too long on this slide, just given the amount of time that we have for this presentation. But I think it's important to note that at 3 degrees, which is the temperature of your fridge, microbial activity really starts to slow down. And of course, we knew that was going to be a challenge with Curtis's project being as far north as it was. It's important to note, however, that the microorganisms do not die at cold temperatures. However, at the higher temperatures, they can. So in some of the work we're doing in the Middle East, we are working on some of those upper limits, whereas here in Canada, we're typically more concerned about the lower limits. This project did, however, demonstrate that the cold freeze thaw cycle doesn't destroy the cell count or doesn't destroy the product, as we were able to successfully degrade the soil piles in question here in this case study over a winter period. I'll leave this slide up for just a second longer, and then if anybody has any further technical questions regarding this slide or anything else, my email's at the end, and I'll be happy to discuss those in more detail with you. I think that we've touched on some of the challenges of doing bioremediation. Obviously, we want to make sure there's a value proposition. This site had a great value proposition. This site was also very well understood. Curtis and his team did a great job of understanding what types of contaminants we were going to be dealing with the material that was coming into the land farm. And of course, we were able to do this application in summertime when it was nice and warm out. Very small window of opportunity that far north. Ex situ and in situ, you know, terms that we see often in remedial design. One of the things I want to clarify, in situ sometimes gets confused with on-site. 99% of the strategies that we're going to be talking about today are on-site, but we do use both ex situ and in situ methodologies. The way that I like to describe ex situ versus in situ, just for clarification, is excavated ex situ above ground, in situ meaning in place. The direct Latin is in place. And so when we're doing in situ remediation, we're typically not manipulating the soils or otherwise excavating them. As you can see here, lots of different methods of getting ex situ remediation done. Again, the name of the game is getting good distribution throughout the soil with the product. You can see here in the bottom left, the whiteness is actually the surfactant, very small amount of surfactant, but it's very reactive, creating bubbles. And we can use that as a visual indicator that we're getting good mixing throughout the soil matrix. In situ, obviously, it can be very simple. Simple spraying of biologics onto a surface contaminated site is a very rudimentary but very cost-effective way of doing in situ remediation. And of course, it can get much more complicated utilizing things like hydraulic fracturing to actually in place the amendments underneath of buildings or roadways. So coming to the project, we did utilize local contractors, indigenous operators. We had a 260 or 270 rather excavator, a large loader, and then the screener that Curtis has already mentioned. We also utilized tanks and pumps that were already available on site. As this was a fly-in job, we really had to rely on equipment and materials that were already on site with the mine operations. We did have local people, indigenous operators, like I mentioned. We had a laborer from Delta. Curtis was on site to help supervise with me. And then we did have a summer student helping us with the project as well. The site was done in a number of different ways. We had some logistical challenges in getting the BioLogix to site at the same time as we arrived. And so we decided that rather than just waiting for it to get started, we processed and we scalped off that 4 centimeter and bigger material. We processed about half the pile, so we had about 500 cubes in a windrow. And then we basically shifted that windrow from here to here in little lifts. And while we're applying those lifts, or moving the lifts rather, we were applying the biologics uniformly throughout those piles. Once we had established everything, treated the existing 500 cubes, we then treated the discharge of the screener. You can see in the bottom right picture there, how we're actually just applying the biologics right as it's coming out of the screener. And that was the treatment. After that was done, that material was brought over to the windrow and it was stacked. And both methods seemed to work very well. We did have success across the site. I'll let Curtis get into that a little bit later. You're on mute, Curtis.
Okay. And this slide here is just the composite sampling results from 2019 for the bioremediation that took place. To preface this, the original unamended soils on site, the F3s coming out of here were around 4,000 milligrams per kilogram, and the F4s around 1,000. So from before everything was treated to afterwards, there was significant degradation of around 45%. The application itself took place in July 2018. We sampled after that in, I guess it would have been September 2018, and we were not reaching our CCME agricultural guidelines in that situation. There were still F3 exceedances. So when we came back 2019, turned the pile over a couple times, and in the end, everything was able to pass for subsoil guidelines. So we were happy that way. In the end, based on that, the entire 1,000 cube windrow was able to be removed from the Landfarm and utilized at subsurface below 1.5 meters of cover. Our intended use for the material was, it was used to cap landfill waste, which is basically just all inert construction material up on a rock pile. We normally cap it with coarse kimberlite rejects, but in this situation, we were able to use this remediated material and clear out all that space from the Landfarm. So it was a huge success on that end. Can go to the next slide. For the conclusions of the project, it ended up that Delta and Rob's team were on site for 6 days. The biologics treatment itself took 4 days. Utilizing that screener, oversized material, about 400 cubes of cobbles that you could see in the photos of one of Rob's slides were able to be removed that way, and a total treated volume of 1,000 cubes were able to be completely bioremediated and removed from the Landfarm itself. So in the end, 1,400 cubes all in all was removed from the Landfarm. This brought Ekati total savings of $194 per cube in comparison to that $464 per cubic meter that would take to screen, bag, and haul all this material off-site on the winter road. And from an environmental perspective, there's a huge win that way as far as a reduction in greenhouse gases, close to 70,000 kilograms.
Yeah, and just on a quick note there, I know that in some of the presentations we've done in the past that greenhouse gas emissions calculation has come up into question. And that's simply just a calculation of the diesel that wasn't burned with trucks going up and down the road. So it wasn't a complex formula. The amount of emissions that 1 liter of diesel creates is found easily. Each province rather has its own guideline. We use BC's guideline in this case for the calculation, but it's just simply the reduction of diesel that would have otherwise been burned hauling this material offsite. And I believe that is taking us to the conclusion, or I guess the closing slide here for Curtis and I's contact information. Again, not sure exactly how the Q&A is going to work here, given the pre-recorded session that we're doing here today. But I know that Curtis and I are both very open and happy to talk about this project. You know, we could probably go on and on talking about this project for 2 hours. So 20 minutes is a very, very quick time for us to discuss it. But please do feel free to reach out. My email is above, Curtis's is below, and we'd be happy to speak to you about this project or any other potential challenges that we might be able to help provide a solution for.
Yeah, thanks for listening, and hopefully we're both there live to answer your questions.
Agreed. Thanks for your time today, Curtis. Really appreciate working with you as always, my friend.
Yeah, thanks, Rob.